We might disagree on this, but that's a different debate, maybe. An interesting starting point would be to try to think what is the difference in the concept of learning between statistical data analysis, of which you're one of the world experts, at least in the implementation of those methods, as opposed to the current generative AI foundation models that we see in chatbots and so on. So how do you contrast those two approaches to learning?
Well, they're not completely opposed, right? So the kind of stuff that scikit-learn is well known for is what we call machine learning or
Yes.
statistical learning. The different ways of understanding it, but you can see it as fitting a statistical model, but your statistical model is extremely rich. It could be as rich as your data. And the challenge that we always put is that it should be about more than memorizing. If I just memorize, I'm just creating a great database. If I create a very big database, I can't generalize to points I haven't seen. To generalize to points I haven't seen, I need to have a notion of similarity and a notion of generalization, and this gets you in some form of statistical modeling. One way to look at it is similarity gives you smoothing. Smoothing allows you to remove noise. And so that is a central point of view of machine learning and statistical learning. And it's exactly the same that is used in generative AI. Generative AI is built, let's take language as a specific case, is built by having models that learn to predict the most likely next word. Okay? So in a sense, generative AI is statistical learning on steroids, and you've just pushed the paradigm extremely far. You've learned on a huge amount of diverse scenarios, and then what we're seeing is that this opposition that I was doing between memorizing and generalizing is useful, but you need to be careful, because one thing we're learning with generative AI is that memorizing a lot is actually useful, because there are only a finite amount of frequent questions in the world. There's an infinite possible number of questions, but the frequent ones are not that diverse, and so you memorize a lot. And so we're back to, well, we memorize a lot, but we still have this notion of similarity, and if I use a wording that is slightly different than the one that we've seen in the training set, that's fine. I can still generate an answer. And so what modern Gen AI is doing is fitting those models that can both store in a fuzzy way what they've seen during training and do some similarities in a good way, and applying this to huge amount of data, and it gives us what we see.
Mm-hmm. I was surprised. I once heard Karpathy in a talk mention that the compression of the training data by those huge LLMs is by a factor of 100. And I thought it would be much more than that, because if you think of all the crap that you see in text that must have been fed in the training data, certainly you can cut out a lot of things because of all the repetitions, as you mentioned, but also because a lot of things is not that interesting. And
well, but they're very careful to choose well their training corpus and do not feed on interesting stuff. It's well shown that if you feed on interesting stuff, you basically are filling up the quote-unquote memory, the parameters of your model, with things that won't be interesting for downstream tasks.
Right.
So they're not, people are no longer feeding in whole internet. They're actually curating a lot what they're feeding in. There's a lot of deduplication, so they avoid to feed in twice the same model. We do the same thing when we do table foundation models. We are very careful about what we put in.
Right, but the sheer number of text that is inputted probably means that not everything can be controlled by humans. But
well,
maybe
so
some automatic.
yes, exactly.
Yeah.
That's yes. It's not humans. It's that We use pipelines that are automated pipelines to do the deduplication, to do the curation, we have the notions of sources. Some sources are known to be reliable. Wikipedia is known to be a reliable source. So of course you're not reading all the text that you're putting in.
Yeah, of course. What would you say is the main difference between statistical data analysis and this GenAI approach?
I would agree, it's extremely different.
Mm-hmm.
In general, GenAI works best when you have things that are more simply true or false. Each data point, if I tell you we are human beings, that's a simple truth. It's either true or false. If you take...
Sometimes I wonder about myself.
Well, what you're saying is that even simple truth actually have nuances. But to an approximation, there is little noise in the statements. If I generate a program, the program is a bit too simple to say that the program is either correct or incorrect. But it's the notion of noise there is a small notion of noise. Now, if I look at traces of patient data to try to predict if a patient is going to have a stroke next year, it's impossible. My data doesn't have the answer. It may have weak predictors that are able to tell me, well, maybe whether a certain probability the patient is going to have a stroke, yes, no, but we're really into subtle statistics. Not to say that there is no implicit subtle statistics behind GenAI because of it's modeling the co-occurrences of words, of contexts. But at the end of the day, GenAI, as we know, it makes hard decisions. It's not giving you, the way we use it, it's not giving you a probability of each world. You never look at vectors of probabilities when you look at the outcome of a GenAI.
So you mean when you interact with GenAI, you get one answer, and that's the one thing you don't
projected
get,
on a single answer.
You've projected, right? You don't get the nuance of
exactly.
I think maybe this is one option, maybe this is another one.
Yeah.
But
and the model is not built for that. Not only don't you not get this, so you basically...
So you don't have the weight in the end that you could look at?
You could look at the weights, and we and others in research do these things, right. And then you could look at the uncertainty that's carried by those weights, but you don't have a model that is built for reasoning, for statistical reasoning on weak signal-to-noise ratio settings.
Right.
Which is very hard, by the way, which is very different from a model, for instance, that a prognostic model in health, that is to say, what are the risks of you having a stroke next year, where you build your whole model by trying to control this notion of risk, this notion of probability of the outcome in a very, very subtle way, and then imposes different constraints on the model.
So, let me see if I understand correctly what you're outlining. Is it like a difference between predictive AI and generative AI in a sense?
Yes, in a sense, yes.
The prediction implies this ambiguity and certainty and
used
also
well.
A balanced output with a certain weight.
Yeah, used well to do.
Well.
Yeah, because you can always do things in a poor way. but
you can use any tool horribly.
Yeah, but if you're actually trying to do predictive AI well, generally at some point that notion of uncertainty might be important.
Right. Whereas generative AI, the output is just something provocative, something plausible.
It's generated.
Convincing.
It's been projected into a hard decision.
Right.
It's also its benefits because it gives you a text that you can read. You could look at the vectors of probability of those words, and
yes.
They would be in a high dimensional space. You could certainly not read them.
Yeah, some sort of superposition of text that goes into different directions. I mean, there are some novels where the two different pages are different stories.
I don't know if they're very easy to read.
No, exactly. When I think about scikit-learn, it seems like the next step of generative AI, in the sense that if you look at the reasoning steps of a generative AI model, if you've asked a technical question or data-based question, you see that it starts writing some little Python scripts to analyze what's going on. So is the current direction to try to enable the Gen AI models to become expert at using properly tools like your scikit-learn statistical library, and therefore to perform like a human data scientist with the level of uncertainty that this implies? In that sense, it seems that it's one of the next frontier of generative AI models. Is it the way you see it?
Yes, clearly. Yes, clearly, and that's what we're doing here.
Okay.
Even though
But you could think it's also two parallel things, or maybe you could think the
so
statistical
let's
comes
maybe
first.
rewind because you've kind of like jumped like super far ahead, which means you're on top of things. But maybe let's rewind. You know, one thing. There's one extra step is that we have. So those LLMs these days they're used in what we call agentic mode. So one thing that a language model is good at doing is generating language. If the language you train it on is a computer language, it becomes good at generating computer language.
Yes.
And so people have realized that then you can generate computer language, and then you can put it in what people call a harness. So it becomes an agent in that it generates computer language, and then it executes it. Okay, so computer language at large. It could be executing a web search. It could be executing something on your computer. So I can tell it, well, write a Python code to find the 1,000 first prime numbers, run it, and tell me what are the 1,000 first prime numbers. It's going to work much better in this sense. What we're saying is that it's using a quote unquote tool. The tool being the Python language that it will run. It's working much better than to try to tell the language model by itself, well, tell me what are the 1,000 first prime numbers.
Because, and it should tell you by memorization.
By memorization, because it's very hard. Because
but it will be limited at some point.
It will be limited, and because one of the value, as we mentioned before, one of the value of this memorization is it's a memorization with compression. Why is it memorization with compression? Because this compression will, first it allows to fit in more information, but also it allows to have analogies. The core of this compression is building analogies. But the analogies give us fuzziness. As a consequence, it's not good to do things like telling me the first 1,000 numbers. So what it will do these days, exactly. Yes. It's all about fuzziness. Even though we're casting, as I was mentioning, we're casting this fuzziness to hard statements when we generate.
Yes.
So people have realized that you can actually have it write tool calling. So write. Yes. Computer code that then gets generated, and then we get into what's known as agentic AI, where the LLM writes the code. It runs it. There's a quote unquote harness that runs it. It retrieves the results, put the results back in the context, and then what the language model is really good at is making sense of information that is not perfectly aligned. That's what it does really well. It does better than a set of rules, for instance. And so, you know, we're getting this back and forth of generating code, running it, putting the answer, and then interpreting the answer in the context of the task, and then iterating. Okay, that's what modern AIs. They're more than language models. They're agents with harnesses. And now back to the question that you were telling me, you know, asking me, well, if you're interested in data analysis, can you use those agentic AI to do data analysis? And the answer is yes. I can take a modern agentic AI and run it. Problem is, and you were kind of hitting exactly what I was saying before, is that the agentic AI is not really good at statistical reasoning. And if you've done a lot of data analysis, you know how important it is to not only squint your eyes at the data and wonder whether, you know, something is noise or signal, but also do the math, do the statistics, compute variances, compute error bars, compute p-values, do graphs, look at these things and iterate. And so then you're going to need tools that are statistical tools or statistical learning tools. So one of the tools that you're going to be using is scikit-learn and the likes to do predictive. But on top of this, you're going to need what we're going to call the statistical harness. So basically some way of conducting the whole analysis that understands statistics. This thing doesn't exist. We're building it right now.
Okay, fantastic. Yeah, can you elaborate a little bit on this concept of harness? Is it just something like a framework that's in place to make sure that the model does not go out of the mission that was assigned to it?
The harness is going to couple the language model to the tools and is going to route the tool calling and coming back. Okay. If you've used agentic,
So it's a mediator between the LLM and the tool.
it really connects the LLM to the tool because there's an agentic loop, right? You get tool calling, information goes back, and this tool calling, how does it feed back the information to the context? On top of this, one thing gets, of course, more complicated. One thing I didn't describe is that, so you've got this agentic loop, and each time, if you do it naively, each time you bump in more information in the context. If you use ChatGPT or the like for a long time, the nice thing is that you've had your conversation for quite a while, and so there's a lot of implicit it has. You don't need to give it definitions again. You can use short words, short sentences to describe full ideas that you've had in the past. Right? But a fundamental problem of LLMs, but the fundamental problem in general, is that when you have too much information, you don't find the information. So when you have very long contexts, the information kind of gets lost. So there's also what people call context engineering, which is really important, which is how do you make sure that only the right information is kept in context? Because if you end up with infinite context, then the information gets lost. Plus, you have compute costs. And so part of the harness is also this, is also making sure that you're dispatching the information between the tool, the past iterations, and the LLM well. And so, for instance, if you're using agentic AI a lot, which if you're a software programmer, some do that, then at some point, you've been running a session for 2 hours or 2 weeks, there's going to be what's known as context compression. You're going to try to summarize a bit because 2 weeks of work, it's just like if you've been doing an experiment for 2 weeks, you probably want to highlight a few key results and stop focusing on a few others.
Okay, so what do you think are the challenges in achieving this usability of sklearn by LLMs?
So once again, scikit-learn is very well used by LLM. The problem is that they can do shit.
You mean it's already used, but at a very
brutally.
elementary level, let's say, and they don't achieve the level of
No,
a
it's
human
used,
expert?
It's used at a very intense level. It has read all the doc, it knows all the API, it's brutal. The problem is it can do all kind of methodological errors, which human beings also do. But you see a lot of things where you have so when you use scikit-learn or any machine learning tool, what's really important to know whether you're doing something that's correct or incorrect is that you split well your training data from your test data, because it's about testing that you've done more than memorizing. Elsewhere I need just a database, not machine learning. And to test that you've done more than memorizing, you need to test on data that you haven't seen. And so that's the theory. In practice, you typically need a lot of data engineering, data processing to transform your data before you put it in the statistical model. And so when you write this code, it's very, very easy to introduce what we call leaks, which is some information about the test set leaks into the training set. And so then it's just memorizing, and then it doesn't tell you how it's going to work in real life.
It's cheating in a sense.
It's cheating, exactly. So the model is cheating. And that's something that we know, but that's something that we know very well, even in plain software engineering. You do software engineering, you use AI for software engineering. In software engineering, you do what's known as tests, test-driven development. So you write a test and you say, well, this is an example of a correct program, for instance. And then you tell the AI, well, here's the code base, I've written the test, can you write the code? Every once in a while, if you're not careful, the AI is going to modify your test. It's going to go like, well, actually, the test was wrong, and this is right way.
It works now.
It works, exactly. It works. I fixed it for you. Now, with it's fairly easy to capture, right? It's quite brutal. You look at the thing, you see, well, you've changed the test. But with statistical learning, there are all kind of very subtle things that go wrong. There's leaking. There is the fact that your data may be biased. You may have missing data. We might be trying to look at analysis of tax to detect, for instance, tax fraud. And we might have individuals where there is missing data. We don't have, for instance, the yearly revenue, which is what we're going to try to predict to detect the tax fraud. Oh, the data is missing. What a naive analyst or a naive model will do is drop this data. It's annoying, it's missing, I can't predict it, I drop it. And now I've dropped the data that's missing not at random. I've dropped data that is actually signal. The fact that this data is missing is signal. I don't want to drop this because if my model does this, it's super easy to evade taxes. The only thing I need to do is try to never answer any question about taxes. I'll be dropped from the system. That's a methodological errors. There's just so many errors that you can do. And that's one thing that we need our statistical harness to make sure that it doesn't happen.
Okay, interesting. So what is literally the harness? Is it like a markdown file that has a methodology?
No, that's what we're getting into agents. That's what we call a skill. A markdown file that has methodology is a skill.
Okay.
A harness is more than that. A harness is really what does the back and forth between the tool calling and what we put in the LLM.
Okay.
So it's code.
Right. But you say it's responsible to avoid all those methodological errors as well. So how would it be aware of the proper methodology in this sense?
We need to teach it, and we need to teach it both by knowledge, which is what you're saying, but knowledge won't be sufficient. We write code that does hard constraints that makes some things impossible, but that also does statistical testing to detect things. This is what we write.
Right.
So it's not only knowledge.
It's hard-coded in this harness that it has to follow
it's
proper
hard-coded,
methodology.
and then the difficulty is that with statistic, nothing is fully white or fully black, and you can't hard-code. It's not that things are impossible. Things are unlikely, but not impossible. So often what we need to hard-code is more a statistical test, a statistical analysis, and then say that things are unlikely rather than absolutely impossible, which is the difficulty.
I see. Yeah, that's super interesting. Maybe it would help to have like a baseline of today. So you say that LLMs are already using sklearn very well. So can you give me an example of what you could do? What is the state of the art that you could do today with an LLM in terms of proper data science?
Well, it depends whether you're a power user or not. I'm a power user, and I implicitly build my harness when I use it because I'm building tools. I'm building Python code. So suppose I'm interested in a data science question.
But I guess I'm saying with one prompt, not like a back and forth.
No, it's a back and forth
between the human and the LLM.
Yeah, it's a back and forth.
So
what I do is a back and forth.
Yeah, I understand, but then maybe it's your...
you asked me a power user.
Sorry?
You asked me a power user.
Right, but I guess I want to disentangle what the LLM can do with just one instruction or one mission, as opposed, just like, it would be like
But this I would push back because in many different applications there is it's been well shown that the way people it's not about benchmarking LLMs in vacuum. It's the way people use them. It's been used
more realistically.
Exactly. There's a very beautiful paper by the group of Luc Rocher in Oxford who shows that in medical applications, real people actually interact with an LLM in a way that is different than the benchmarks. They're gonna ask questions. Those questions are going to be targeted in a specific way. On top of this, the LLM tends to be tuned to answer in a pleasant way, and so it's going to create a feedback loop. And the kind of analysis that you get with an interaction with a human being is a different analysis that in a vacuum-like setting. So how you ask the question, how you interact, is very important. So back to your question, sure, I can do benchmark. We do this. I can do benchmark where I give a data set, a prompt, run the analysis. It works. It kind of depends on the problem. On some problem there's bias in the data. Depending on whether you use our tools or vanilla tools. If you use vanilla tools, it doesn't always find the bias. Quite often it doesn't. With our tools currently, it finds the bias more often. So yes, that's the kind of fire and forget mode, and of course we're working on it because it needs to be as good as possible. It's cold start, but we don't want to stop there. Because we don't think that this will be sufficient to capture enough situations. So what I'm saying basically is we're not automating data science. We're not replacing data scientists. We're giving a tool to a data scientist that they can use to be more efficient.
So the human will always remain in the loop.
I don't know about the always, but in the
supervise.
near future, I would like the human to stay in the loop. In the near future,
In the near future.
yeah, if people are going to do data analysis for medical purposes, and they've just told me, well, I've given all this data to an LLM and I trust the results, I'm afraid. If they told me, oh, I had a competent biostatistician who was using the LLM and the harness and who was checking everything, then I trust.
Yeah, you can imagine that the LLM, which worked alone, not only produced like a prediction, but also a report explaining the methodology
Yeah.
and the different decisions that were made.
Yes.
But then, of course, you would need at least some level of expertise
Yes.
to read that report
Yes.
and decide whether it makes sense or not.
But that's really important because typically in statistical question there is no simple truth. But that's something people hate, right? They always want a simple truth. It's true of everything in life. Politicians, they want to know that this thing is going to do is going to improve GDP, change employment, things like this. It's never simple. It's always, well, first there's things are likely to be true or false, but everything is entangled.
Yeah, I find this funny because indeed it seems that the most beautiful things are in fact ambiguous things.
Yes, they
and
are.
this is also the most interesting to
Yes.
think about.
Yeah.
But there's this tendency, of course, because of maybe cognitive overload, you want, okay, it's black or it's
Yeah,
white.
yeah.
And you don't want to
And
have
it's
to engage in anything.
Totally
gray.
cognitive overload. It's
Yeah.
true. And so, back to your question, yes, we're going to need some, I don't want to say specialist, but at least somebody with some, thinking to have an idea of what's going on. Maybe we can, when we're working on this, we can make the user experience as good as possible. One thing I do not want is to say, well, you can use this thing only if you have a PhD in statistics. I think that's super toxic. It's a very bad behavior.
Yeah, of course, scikit-learn democratized the use of statistical tools. Yes.
Yeah. And it democratized, but it didn't dumb down.
No.
As you know, our documentation, we always try, and it's really hard, we always try to have, simple words, but also statistical thinking, links to the articles, to the Wikipedia page. That's exactly what we want to do. We want to simplify, but not dumb down. We want to explain, but not hide.
Mm-hmm. Okay, so we were saying that the goal is not to completely replace the data scientist, but to provide him with LLMs that are connected to a harness with sklearn tools, statistical tools. And with that, he could create a much more powerful data understanding approach.
Yeah. So I wouldn't say LLMs. I would use the term AI systems, which is
Generally AI.
Yes, because it's not only an LLM, right? It's an LLM. It's a harness. There's a lot going on, much more than an LLM.
Yeah, I don't know how to call them nowadays. Are there
AI
agents,
systems.
foundation models, or
AI
because
system.
AI systems? I mean, is the work doing by the word system? Because AI, in principle, could encompass all of it.
But when you look at what's going on, there's so many different aspects of AI, including AI from the 80s. You might have, if you're using AI for theorem proving, then you have theorem provers, which is really related to AI from the 80s and 90s that are blended together with LLMs. And what really works is this combination of both.
Right.
So that's why I like, and I'm not the only one to call these AI systems.
AI systems, as opposed to statistical data science approach, or what?
To me, statistical data science is a specific application. So theorem proving doesn't require statistical reasoning on data. And it's a perfectly legit and super powerful application of AI. If we're going to do AI for data science, then we need this.
Okay. So this is, I guess, the current state of the art of what you can do with data science with those AI systems. And you're outlining also what you're currently doing now at Probable, strengthening this data science methodology in this context. But maybe we could like project ourselves a bit further ahead and think what would be the obstacles for the AI system to be in charge of the full data analysis pipeline.
The question is, how far can we go? And I don't know. We've been surprised in the past. We can go much further. So my question, I don't know there, is if we start seeing so many statistical analysis, if our tool starts, seeing a lot of statistical problems, then it could start to bake in the statistical understanding and to become basically expert. To look at the results of experiments and to have, it's not only a feeling about, whether something is statistically meaningful or not, it's a feeling, but when you work, you back this with, well, I'm going to compute confidence intervals, but I'm also going to interpret my confidence interval, having known that I ran many experiments, and so I might have a multiple comparison problem, and I need to slightly increase these error bars. This is what you get when you have an experienced data scientist. So, or I might be looking at this data. I know I can predict, but I worry that I might have an implicit interventional bias in what I do because I've seen this many times. And so, in the future, our dream is that our system actually captures these things and starts behaving like an experienced data scientist.
So data science is quite rich and interesting because it differs from maybe some other computer science applications. Maybe if you're just writing a simple software, you can have a very linear approach. So you can define the goals, and then you can have a plan, and then you start coding from the first line, and then it's finished, and you have your output.
The problem with data science is that you have data, and the data is never what you think. And so, as you say, you need to react to the data.
So there's a certain iterative process. Yes. In fact, research, the word search comes from the word circle, actually. And so when you do research, you recircle.
Running around in circles.
Exactly. So is this the hard part for those AI systems, is to understand that they have a task, but the task itself might need to be questioned and then maybe redirected, and every step is potentially suspicious. As you say, you can yourself as a researcher, you can have biases, or you can maybe forget about something. And so every step requires almost like a meta-analysis of how it could introduce some mistakes in the ultimate result.
So in a sense, that's why we have agentic systems. They're in a sense not too bad at this. Fact of life is that the theory that we can specify something, and then once the specification is built, we throw it over the wall, engineering builds it, never works. There's always, you realize real life isn't the way you specified it, even when you do standard software engineering, even when you build buildings. And so there's always this iterative approach, and that's why we ended up going for agentic system where you do back and forth with them. This is how we work. Now what I've seen is that on data science, the problem is that there is maybe much more iteration because you don't know the data, you discover it. When you discover it, you've got surprises. It doesn't look like the way you think. On top of this, it's all weak signals, so it's really hard to interpret. And so the agentic systems, they really, at some point, they get lost into places where they shouldn't go. They start accumulating error. They've done a mistake a long time ago. They keep it, which is also true of normal coding, but it happens more in data science. And that's where we need a better harness and a human being to figure this out and to get the system back on track. So typically when I work with it, I see behaviors that that don't feel right. As an experienced data scientist, I see something and it doesn't feel right. And being lazy, as most people, it's not like I'm going to run my own analysis in parallel, or I'm going to open up the code and check what the AI has done. What I do is I tell the AI, well, this doesn't seem right. There's this thing here. I don't trust it. Investigate.
Like you would do with a PhD student.
I totally feel like I'm supervising a PhD student. Exactly. Investigate. And then the AI goes, woo, 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 and of course, I'm quite careful when I say investigate it. I typically say, well, you're going to run experiments, you're going to use test cases, things like this. And then the AI comes back and quite often it finds a problem. Every once in a while it says, well, there's no problem. And then, sorry, but exactly like a PhD student, I'm going to trust it, but only weakly in the sense when it comes back and says, well, there's no problem, I don't have time to investigate, so I'll say, okay, let's move along. But I keep in my mind that there's something weird. And if that thing weird, I don't understand after a while why it's going on, I may do my own research on the side. Then I may actually dig in more and maybe dig in myself and then, take my the AI, which in my head I picture as a bulldozer, take it, put it aside, and literally work a bit on the code myself. That's what I do.
Yeah, so in data science, there's maybe a methodology that could be articulated explicitly. You could say this is a good approach, but maybe the type of thing that you're describing here, something that feels off, does it come from your intuition, from your experience, or is it something that you could say, no, it's actually against this kind of principle? Or
well, it comes from knowledge, so principles, yes.
From principles?
Yeah, from accumulated knowledge.
So what would be the obstacle to explain those principles very clearly to the AI system, and then they would refer to it?
It's just a matter of engineering.
And a matter of engineering, and also maybe the fact that it will be a very long process, and the reasoning could shift away from the...
Then of course the danger, and that's why I'm saying it's a matter of engineering. You also need to be careful, because if you do it in a naive way, you're going to do context overload. You're going to blow up the number of iterations. Your AI is going to run many times, which is going to mean it's going to use many tokens. Maybe you've heard that tokens are expensive, and so you're going to have an extremely inefficient system. That's the danger, because we're looking at very weak signal to noise ratio. The danger is to have incredibly inefficient systems that are trying things at random, which is what we want to avoid.
Right. So it could double check everything and
and given that things are noisy, it could try many things and get lost by the noise.
Right.
And when I say it's just a matter of engineering, it doesn't mean it's easy.
So it's better to proceed by kind of small chunks, and every now and then have a human say, okay, this looks good, I think the next step is in this direction.
Well, from an engineering standpoint, we want to reduce the overload to the human beings. So the question is how can we move this bar? Can we have the AI run in a way that it calls for help only when it needs? That way the tasks that are unsurprising and simple get solved, but the complex ones actually get solved via this interaction between the human being and the AI. That's the goal.
And so you're developing SCORE also for evaluation, I guess, for the process. Does that fit into this?
Absolutely.
Yes.
SCORE is developed for evaluation. Evaluation is important for human beings and for AIs.
So it can be used by both. Yeah. It's constructed
it's
this way.
Part of what we call our harness.
Okay, I see. And then at every step, you can have some reassurance that things are going into the right direction.
Yeah.
So what is interesting with data science is that there's this element of surprise that you mentioned. So things might not go the way you want, or maybe what you end up discovering is not the thing that you were looking for in the first place, but it's something even more interesting that you hadn't suspected. And probably, at least at the moment, this is something that AI systems would really struggle with, because they're very focused.
They're better than non-AI systems, right?
Okay.
They can react to things, especially in an agentic way, right?
Right.
And they can interpret contradictory information better than a system of rules, for instance.
Right, of course.
They may not be good enough for what we need, but they're a start.
Right. So let's imagine in a few years that we have more powerful systems that are able to not go off track too much, but maybe they do a little step of analysis, and then there's maybe another model that says, does that look good? Yeah. What is the leanest next step and the most effective way to proceed? And then you could imagine that they run for days or very
So
long
people
time.
have been using them to run for days. Our question is, can we make this more efficient? It doesn't seem currently
So it's
very
an
efficient.
efficiency problem at the moment.
Well, depends. So the people who've been using them to run for days are more the experts.
Yes.
So we have two questions. Can we have non-experts use them? Can we make the experts' life more efficient? Does this
Right.
converge to a single system? My answer is,
So
I believe
when
yes.
you say run for days, is it still in this back and forth,
Yeah.
or is this alone?
Yeah, totally back and forth.
Back and forth. Okay.
No, not back and forth with the
the
user.
human.
No.
No, the AI system itself goes back and
Yeah.
forth, but on its own.
Yeah.
Okay. And it achieves remarkable results?
Well, it's always about the glass being half full or half empty, right? Some people are, there have been, reports like, oh, what an amazing result. I look at those results, it's not like something a human being couldn't find, but it's true that it would require a lot of work. So maybe what's remarkable is, well, I just, burnt, X many hours of GPU compute, and it did something that would require a week of work from an expert human being. So if you just look at cost, it's cost effective.
In this sense, yes. If we try to extrapolate, I mean, it's not too much of an extrapolation because we've seen recent results in mathematics, like with the Erdos problem, the unit distance problem. There was a decisive advance done by an OpenAI model that really impressed the mathematical community. And you can imagine that this kind of breakthroughs would be more and more frequent, not only in mathematics, but other sciences and beyond. And
Well,
so
here there's
what
a
about
jump.
data science? What is your gut feeling about data science?
But here there's a jump, and people keep doing it, and I don't agree with this jump. Math is, I don't want to say it's easy to know whether it's right or wrong, but all the work from the provers, the logic provers for the last at least 30 years or more has helped us to check that if we have a sequence of statement, that sequence of statement is consistent. And so it helps us checking whether a proof is right or wrong. So it's a closed system that lives in a computer, that can live in a computer. It's a closed formal system that can live in a computer. And at the end, we can say right or wrong. That's only true of math. Nothing else is like this in real life. You're going to need data, and even in data science, in data science, we take data and then we munge it like crazy. At some point, you've overfitted it, and there's nothing you can do. You've basically squeezed all the juice out of your data, so you're going to need new data. So even in data science, we need new data. And now I talk about physics, chemistry. You're going to start to have to intervene on the world to acquire data, and so AI for chemistry will be used in loops where the AI runs, and then you have an experiment. So if you're looking at synthesizing molecules, you have an experiment that actually runs the experiment because you need this data point. And so back to AI for data science, the difficulty of AI for data science is that things are neither, simply true nor simply wrong. And so how much will this success of AI for math carry over to data science? Well, partly, but at some point you're still going to need more data.
Right, so it's true that maybe we're starting to see results in mathematics because of what you say. It's like more square and fair, and then you can see how the proof is just a logical chain of steps. However, I think this recent paper about the Erdos problem is not like using some prover or like a lean approach.
I'd be surprised it's not internally. I mean, I haven't looked at it, but I'd be surprised internally the system. Once again, I think lean is part of the harness. You don't see it, but it's part of the harness.
It's possible, but I think it's also combining some pretty high-level concepts, and it's not just proving like the logical steps one by one.
Of course, it's
like,
not only lean. I'm not saying it's because of lean it works. I'm saying lean is important to this.
Yeah, I don't even know if lean was involved at all in this proof, but it would be interesting to check. But of course, I mean, regardless, I think of course it starts in mathematics because of this kind of purity of right and wrong, which does not happen in other sciences. So we start to see those breakthroughs performed by AI systems in mathematics. That makes sense. But I think it will gradually shift and have this ability to deal with more fuzzy data. And it's very likely that it will also have breakthroughs in, for example, data science.
I think it'll be incredibly useful in data science. But what I want to mitigate is to be useful. Data science per se isn't a goal. I mean, aside for a data scientist, data science is used for a purpose.
Yeah,
To
you're
be
right. It's not a
useful
field of
for the
investigation and so on.
purpose, then it needs the bottleneck may be the field of application.
Yes.
I'm particularly interested in health and medicine. This is really
Right.
where I'm passionate about.
Yes.
And we're going to need data, we're going to need intervention, even simple things, drug repurposing. I have an existing drug. Is it useful outside of its original context? If it's is a molecule A useful for disease C? If it has never ever be given to an individual that has disease C, I cannot conclude empirically on this question at all.
Mm-hmm.
And there's much more of this than one would think in real life. This is what we hit all the time. And then what you need to do? Well, then you need to start giving the molecule to the individual. That is an intervention question. It's an intervention on human beings giving drugs to people. It's not an intervention that we will automate for ethical reasons because things happen to people when you do this. And so, bang, we're putting back in the medical doctors in the loop. We're putting back in the experimentation. And, to have real impact, we need to have these people working together.
So you're saying that the first step of data science is just data collection, and
Yes.
this is out of reach of AI systems, of course.
It's not
because
completely out of reach. Okay, so to give you another example of cases where this is done is ad placement.
Yes.
Yeah, so ad placement, they do this all the time. They modify the ad to see if it works or not. And so then they have the whole feedback loop. They can act on the world, they can analyze the data, act on the world. Why can they do this? Well, because the cost of an error is very small. I give you the wrong ad, you might be annoyed, especially if I have a bit of safety on my ads and I'm not showing outrageous things. In such setting, then the AI can move forward very fast. And the kind of techniques that are used for ad placement are very related to the kind of techniques that were used with AlphaGo to discover new strategies. So when you're in a world where you can very easily play with the world, then progress is super fast. The difficulty is when you're in a world where you can't easily play with the world.
But then you could also say this of a human data scientist. He will also not be allowed to play with the patient's lives.
Yes, of course.
Yeah.
What I'm saying is not that AI won't make things faster, or that AI is not a net improvement. But what I'm saying is it's not. The fact that we get much better at AI isn't going to suffice to solve all the problems. They're going to have other problems that are outside of our computer that are going to be important.
Okay, I see. So you're extrapolating in the situation in the future where we have super powerful AI systems that can perform data science fully and very satisfactorily and following all the principles. But you're saying, well, that was kind of my next question. What is the role of human researchers or just human beings in general when there are systems that are so professional and so effective? And what you're outlining is that the role would be to actually interact constructively but potentially destructively with actual people's lives in case of health.
To mediate, the role would be two things: to mediate the connection between the AI and the external system.
Yes.
But also to steer the AI. So to ask something that's very important in science and that we often undervalue is asking the right questions. It's known as problem framing. So figuring out what's a question that may have a well-defined answer is a very difficult problem. The biggest advances of science come from questions, not answer. You mentioned the Erdos problems. If we go to physics, There was things like the Einstein-Podolsky-Rosen debate. The question, of course, those questions take a long time to answer. But a good question is incredibly important in medicine. Now, of course, you can suggest good questions, and the AI can help. But overall, steering the AI in bringing it back to what are the good questions, I see as an important problem for quite a while.
Yes, I agree. And I heard in one of your talks you mentioned that if you put things in categories, it will also have the effect of shaping the world that you perceive around you.
Yeah.
Was this a quote by someone? Or?
It's a whole body of work by Desrosiers. Alain Desrosiers was a fascinating person. He was somebody who had both training in thinking in sociology and in statistics. And his point of view was that you can't do quantitative social sciences, so study societies and people by doing only one or the other, only sociology or only statistics. And the problem of categories, which you mentioned, which is once you put people in a box, well, they start behaving as the box that they're defined. So it has effects. It's non-neutral.
Right. So yeah, this problem of which questions are we asking. So it's very important, and I think it seems to be, because it shapes the actual world we are in. It's very difficult, but maybe it's a lack of imagination, but to think that an AI system could be formulating new questions that actually transform the world we are in, because they shed some light on certain aspects.
I'm convinced they can help formulating, because
yes.
Let's take an analogy. I think none of us these days work without a Google search. We Google search all the time. In a sense, AI systems are Google search on steroids. So, they know more things than we do. So interacting with it helps us retrieve existing body of knowledge, which we can use to ask questions.
Right. Yeah, it's very good to get a clear landscape vision of everything that has been experimented with in the past by other researchers. So
as long as you have critical thinking, because it hallucinates. I mean, just yesterday I was doing exactly this, and of course it had hallucinated results. Okay.
But indeed, if you want to go one step further, you need some sort of creativity. And that
build abstractions, build high-level abstractions.
An abstraction, right. But it's also something both very abstract, but also maybe connected to our guts and to our hearts, and something very embedded in a sense that allows us to question what is reality itself, in a sense which you cannot easily imagine that a system that was built in a certain worldview would be able to outgrow this worldview.
Okay, so what you're saying is that AIs are built in a worldview. That's it's true. As anybody of knowledge, they capture a worldview, and there's this notion of social epistemology, which is that you believe certain things are true because the information that you get from your social circles basically validates this worldview. And the AIs are, of course, built like this. When we choose, I mentioned earlier that we're very careful about what we choose to feed in an AI. What we choose to feed in the AI builds an implicit worldview. And we've shown on simple problems, we've shown, for instance, that AIs have a much better knowledge of Western famous people than is East Asian famous people. They hallucinate much more on East Asians than on Western. So it's clear cultural bias. So then the question that you're asking from a scientific perspective is, well, we're kind of stuck to our worldview. How do we do a leap beyond our worldview? In history of science and epistemology, this is the notion of paradigm shifts. It's been studied by
Thomas Kuhn.
Thomas Kuhn, exactly, and the famous introduction of quantum mechanics, of relativity, or paradigm shifts. And of course, it becomes really hard to do the paradigm shift because you're kind of stuck in your paradigm, you're stuck in your worldview. And to do this paradigm shift, you need two things. You need first evidence that contradicts your current worldview, and second, an ability to say, well, this evidence is actually strong and I need to rethink my worldview. And if you're having a purely statistical reasoning, there's a danger this doesn't happen, because by construction, this evidence tends to be weak. You don't have a lot because you don't have many data points outside of your worldview, because our worldview is consistent with our data collection, because our worldview matches the constraints of our data collection, but also our worldview controls our data collection. We do data collection because we believe in this worldview.
So in that sense, it almost feels like we humans are stuck in our worldviews. It's very hard to break it and then perform a paradigm shift. It happens like once a century. So in this perspective where we appear to be a bit stuck in our worldviews, maybe AI systems have an advantage there, because probably they don't have opinions, and Einstein
AI systems
really
can help bridging the incommensurability gap. They can help accumulating evidence more than an individual could, but they need statistical reasoning.
Right, but imagine, faced with the data that at the beginning of the 20th century, physicists were seeing that were contradicting the laws of classical mechanics, for example. And so they had to imagine that, in fact, you have to give up absolute realism. So you cannot decide that the particle has a specific position and momentum, for example, at any time. This is hard for a human to do, and even Einstein struggled. And in this case, you can imagine that an AI system would not have had any remorse to just slash.
It's completely bound to its training corpus. It's completely bound to its worldview.
Yeah, but the philosophical position of absolute realism was just a possibility among many, and it could have been aware of that, and then it could have thought, well, I can maybe remove this hypothesis, see what happens. Oh, okay, now I have agreement with experiments.
We all do, but I don't like using words such as thinking for AIs. They're computer. They're statistical machines, as we said before. Exactly. And then second, maybe the thing is it's purely working based on likelihoods of things. And given that it has implicitly, AIs don't have philosophy, but they implicitly embark the philosophy that they're trained on. So I don't know. I think
I see what you mean, but what I'm saying is that if you were just a classical physicist at the beginning of the 20th century, your worldview would be very stuck in absolute realism, for example. But if you had also some philosophical culture, which the AI system would have, you would realize that this is a pretty strong and perhaps unnatural assumption to make, and therefore you would have been very likely to
I don't know. I think you would have the philosophical culture of the time, and I think
yes, but in your subfield, but the AI system will have the culture of not only of the time but of the entire history, and also in any fields. Therefore, it's in a position of much more flexible thinking, maybe.
Maybe I think it's biased, but it needs to be as biased by the frequency of things it seems. It's well trained. Once again, it knows better, knows more about Western individuals than East Asians, and so just the fact it's a well-known bias of human beings, but it's also a well-known bias of AIs. The fact that something comes up very frequently in the training data means it's right. I mean, that's how.
If you repeat something
exactly
enough times, it becomes correct. Yeah, sometimes, it seems true. So if we zoom out a little bit, maybe think about your own career and research. How would you say you learned effectively and then achieved the level of creativity that was required to achieve all of your successes with scikit-learn and research?
Well, maybe I can go back to kindergarten.
Okay.
or elementary school.
Yes.
I think I was very different, not in a good way. I think I was very.
Well, it worked out.
Well, yeah, but it was very different. I was very socially awkward.
Okay.
And there was no way out, right? I was socially awkward, and so I basically, the first thing is that I learned to cope with it. I learned to accept I was different. That's the first thing. Is accepting you're different.
Yes.
Okay, so that was my
To be
first.
an original thinker is the first step. Like,
Well,
to allow yourself
I didn't know how to dress. I didn't know how to behave. I didn't watch. We didn't have TV at home. I didn't watch the same shows than the others. It was completely disconnected.
Yes.
And so kids made fun of me. It was hard, but as a consequence, when I grew up, I was like, it's okay to be different.
Yes.
That's the first thing. And then a second. I started in physics. I did a PhD in physics. I did a postdoc in physics, and then actually I loved computers. And then I just felt the reason I started in physics is because my father was doing physics, so I wasn't that different. It was just following the
Right.
footsteps of my father. But then I decided I wanted to do something different, and just by chance I joined a group that was doing a brain image analysis. I joined the group because I wanted to do data analysis. I thought that was something I loved in physics. I joined the group also via open source, and then I first thing is I learned to like it. I learned to like data analysis, but I was sitting in a cognitive neuroscience building. I learned to have good friends in cognitive neuroscience, to talk with them, accepting my difference and basically enjoying it, talking with different things. We'd have, passionate conversations at coffee breaks. I would completely disagree with them and not understand at all what they were saying. And then I would read things, and then I started wanting to contribute to cognitive neuroscience. I did a few papers there. It was hard and fun, and basically, once again, accepting. I think one thing that really happened is that I did a PhD in a very privileged environment. Many years later, my PhD advisor got the Nobel Prize. I was with people who were kind of the people to be with. And when I decided to move to another field, it felt like I was, taking huge career risks. And having done it once and having moved to another field and having, experienced that moving to another field was fun, and actually the things that I had learned in a kind of soft way would carry over, also I think stimulated hugely my creativity, because I started having less fear of the unknown, less fear of being completely the oddball, of learning to ask stupid questions because I didn't understand anything. We all do, but basically learning to reformulate, learning to bridge ideas, learning to be curious about things that I didn't understand, and it felt okay to ask questions about them. I think that was what was really important, accepting to be different, and then, actually moving brutally across different environments, and each time, trying to figure out what are the things that this environment can bring me.
Yeah, that's fascinating, because from what you're saying, it seems that creativity requires some sort of unicity or difference
By construction, right? Elsewhere, you're just repeating.
Exactly. Which seems to be not what the AI system that we develop are trained for. They're trained to be very generalist and to do something very conventional but plausible and convincing in all the different fields. And you cannot easily imagine an AI system that would be the oddball and certainly come up with something that's completely unique to its own way of approaching things.
Well, if we put many terms behind AI systems, but if you train an AI system to capture all the world knowledge, which is what we do, which is incredibly efficient, because there are many billions of individuals on this planet. They're all clever. They've all solved things, and if we can know what every single individual has solved, we know a lot. That's what modern AIs do. And that's incredibly useful. Then, in terms of creativity, is this creativity that, somebody else had a good idea, you don't know it, but the AI tells it to you. Now, if you take another setting, which is, for instance, what AlphaGo did, which is you have a clear goal and you're allowed to invent in this space, and you have self-play, which tells you whether you're making progress or not, then you get unique creativity. So AlphaGo was seen as extremely creative by professional Go players. Professional Go players studied the strategies of AlphaGo and were really surprised and said, well, they're new strategies. Why did it happen? Because the goal of the AI, goal in an engineering sense, with the self-play loop that tells it whether it's making progress or not, was to be creative. But back to the points I was making about, we're not only limited by theory, we're limited by experiments. You can't replicate this everywhere, because you need to have this ability to have feedback function that tells you whether you're making progress or not. And if you're interested in the real world, you're going to get this feedback function only if you interact with the real world. And you can't always interact with the real world at random.